Now another lesson on wave optics using Huygens principle. Now we will prove laws of reflection. That is, angle of incidence is equal to angle of reflection, and the incident wavefront, the reflected wavefront, and the normal, they lie in the same plane. Now look at the diagram. This 1, 2, 3 are rays coming from infinity. A, D, B, this one is a plane wavefront, and we know a wavefront, as in this case ADB, is normal to the rays. Means ADB is normal to 1, 2, 3, means this angle is 90. Now M1, M2 is a plane mirror. This is the back side of the mirror, this is the front side of the mirror, and the light will be reflected from the front side. The wavefront will be reflected from the front side. Now at point A, this is a normal. At point A dash, this is a normal. This is the normal to the mirror at A. This one makes angle I, that is angle of incidence. Now let M1, M2 a plane mirror, ADB a plane wavefront approaching M1, M2. ADB is a plane wavefront, means all the points on ADB, all these points are identical in the state of vibration. That is same thing as saying they are in phase. According to Huygens, each point on ADB, each point of ADB is a new source of disturbance according to Huygens principle, and those new sources are called secondary wavelets. Now look, first this part will arrive at A and will be reflected, and this one, when B arrives at A dash, traveling a distance BA dash, the disturbance from A must have traveled to this side. Let it be AB dash. We will discuss how much is AB dash. Let T is equal to the time for the secondary wavelet from B to reach A dash. The secondary wavelet from B, according to Huygens principle, let it take time T, small t, to reach from B to A dash. So this distance BA dash will be velocity of light, that is c into time. Velocity of light into c into time. Now, therefore, the secondary wavelet from, this is also again a source of disturbance on this wavefront. The secondary wavelet from A, after getting reflected, will travel the same distance. Means AB dash is equal to velocity of light into time. Now with A at the center, draw an arc at B dash. With A at center and taking this AB dash, that is equal to CT, velocity of light into t, draw an arc like this. Now draw a tangent plane A dash B dash. Now from A dash, draw a tangent to this surface, that is equal to A dash B dash. Now in the same time, the wavelet from D will travel the distance from here to here and from here to here. So this is the common tangent. Therefore A dash B dash, rather A dash D dash B dash, A dash D dash B dash is the secondary wavefront after time t seconds. Now let us see, if this angle is I, then how this angle is I. Now look, this much is 90, and from here to here is also 90. Now from this 90 and from this 90. This is the common part. This is the common part. So I take out equal amounts from this 90 and from this 90. So the remaining part, that is this and this and this, are equal. Since this is I, therefore this will also be I. I have taken out equal parts. Means this is 90 and this is 90. So this is the common part. So when this is taken out, therefore this angle will be equal to this angle. If this is I, therefore this will also be I. Similarly at A dash, this is the normal. This is the reflected ray. So this is equal to angle of reflection R. Now look, this wavefront A dash, D dash, B dash. This wavefront A dash, D dash, B dash is normal to the rays 1 dash, 2 dash, 3 dash is normal. Therefore this angle is 90. Again to the mirror, this line is normal, that is this angle is 90. So the common part is, so this is the common part which is taken out from both 90s. So therefore the remaining angles will be equal. So the remaining angle is, this is R, and the remaining angle here, this will be also R. So this is R, therefore this is also equal to R. So now therefore angle BAA dash is I, as I explained you, from both 90, this 90 and this 90, the common part is taken out, therefore both are equal. Since this is I, this is also I. Now is I, and similarly B dash A dash A. Similarly B dash A dash A, that is this much, is also 90, because I explained you. Now this is R, this is 90, and here I am explaining it here, and this is 90, this is 90. So the common part is this, that is taken out. So whatever left will be equal. Since this much part is R, on this side equal will be R. So similarly, angle B dash A dash A, angle B dash A dash A is also R. That is this one, not this green one. This one is R. Now look at the triangle. Now triangle A dash B. Now triangle A dash B. A dash B dash. A dash B dash. There are two triangles. In both the triangles, this is 90 here, this is 90 here. Now A dash is the common side. In both this triangle and this triangle, A dash is the common side. Angle B is equal to angle B dash, that is equal to 90. Angle at B and angle at B dash is 90, because this wavefront is normal to the ray. This wavefront is normal to the ray 90. Therefore both the triangles are congruent. Congruent means exactly identical, their areas are also equal. Therefore angle I is equal to angle R. Therefore angle I is equal to angle R. Angle R in triangle B dash A dash A and angle I in triangle BAA dash are equal. That is angle of incidence. That is angle of incidence is equal to angle of reflection. Again ADB A dash D dash B dash. Again ADB A dash D dash B dash. This is the incident wavefront. A dash, D dash, B dash is the reflected wave front, and the normal here and the normal here. They are lying in the plane of the paper. So the incident wave front, the reflected wave front, and the normals all lie in the plane of the paper. So this was the first law of reflection. This was the second law of reflection. So laws of reflection is proved. I could using Huygens wave concept, that is wavefront concept.